Okay, so we've just looked at methane. Now let's look at the molecule ammonia, which is NH3. And like we did with methane, we're going to start out by looking at the electron configuration of the atoms that make up NH3, nitrogen and hydrogen. Nitrogen is 1s2, 2s2, 2p3. That means it's got 5 valence electrons. Hydrogen, 1s1, as before, 1 valence electron. Now there's 3 of them. All right, so let's look at the Lewis structure. And I think we've done ammonia before as a Lewis structure, so it's right there. Notice, though, that we've got the valence shell, the octet rule is satisfied, valence shell is full, but we've got what's called a lone pair right there. That lone pair means that there's no atom attached there. It's a lone pair of electrons. It's not participating in a bond, but it is definitely there, and that is kind of the crux of valence shell electron pair repulsion. That lone pair is there. It does affect the geometry. Because there's 4 pairs of electrons around the central atom, nitrogen, the electron structure is still tetrahedral. And remember, tetrahedral was this. Is this because that makes the bonded, in the case of methane, it makes the bonded hydrogens as far apart as possible, or those bonds, those 4 bonds, as far apart as possible from each other. Now, what I'm going to do is I'm just going to remove one of the hydrogen atoms from methane and show you what that looks like. Okay, here it is. Okay, now we still have 4 pairs of electrons around that central atom. Now, in this case, that central atom is a nitrogen, not a carbon. You've got 3 hydrogens bonded to it. But because you still have that lone pair up there, and it does take up space, and it repels the other paired electrons in the bonds, it does affect the geometry. So this geometry, the molecular geometry, is called trigonal pyramidal. It looks like it's got 3 hydrogens pointing down, and that one lone pair is pointing up. Now, of course, we can rotate it in any direction we want. There's no particular order for it. But if we rotate it like that, we see immediately why we call it trigonal pyramidal. Now, really, though, to look at the molecular geometry, I'm going to show you what the model looks like. It'll look more like this. Molecular geometry, trigonal pyramidal. We know that there is an electron pair up here, and that is taking up space, and it's forcing those bonded hydrogens down to form that trigonal pyramidal shape. So that's what's going on with valence shell electron pair repulsion for ammonia. Next, we're going to look at another molecule, water.